All right, so the biggest thing that's different between the 220, 230 and what you did last semester and the 130 class is the introduction of the Heparin Protocol. Everything else is pretty much the same. You have the same type flow rate type questions. Let's see. Oh, okay. So there's a couple things that are a little bit different, like 22 and 23, where they give you an infusion rate in units per hour, and they want you to calculate flow rate in milliliters per hour. So I'll show you those real quick. So 22, 23, and 24, and then we'll jump into the Heparin protocol, which if you've tried it, maybe you had some success with it. If not, I'm going to try and help out with that. So like I said, I'll start off with 22, 23, and 24. All right, so for question 22, it tells me I have 0.45% normal saline, 1,000 milliliters IV with heparin 25,000 units, and it's infusing at 1,000 units per hour, but I want to know the flow rate in milliliters per hour. So we have 1,000 milliliter IV. It's got 25,000 units in it. And it's infusing at 1,000 units per hour.
I can't really see that. I'm sorry.
That's okay. I'm getting it in just a second. I'm just writing down the stuff for myself so I can because I got to close out the screen.
Thank you.
You're welcome. Thank you for letting me know. Okay. All right. Now you should be able to see. Okay. So these are the key factors in this. So, and the question is, what is the milliliters per hour? And your question might be, I don't know, how do I even get there? So the first thing is we know the infusion rate is 1,000 units per hour. What we don't know is how to get from units per hour to milliliters per hour. So I'm going to show you. This is another one of those types of questions where doing ordered over half doesn't really help. And so you need to have a process. I'm going to show you dimensional analysis, but if you have another way of doing this and you're getting the right answer every single time, then continue to do it that way. So there's two ways to kind of go about setting this up, but I recommend starting with the flow rate. And then, so basically you're going to go flow rate conversion to the new flow rate. So I'm going to start off by writing 1,000 units. I don't want units per hour. I want milliliters per hour. So I need to know, I need a way to convert that. And this is where the 25,000 units of heparin in the 1,000 milliliter IV bag, and I know I kind of wrote this backwards, that's an important thing. These things are in the bag together. We want to connect these two. There's 25,000 units of heparin in the 1,000 milliliter IV solution. So what I'm going to do is I'm going to organize this so that I can get rid of units and have milliliters. If you ever get stuck on this because dimensional analysis is not your thing, just remember, what are you looking for? You're looking for milliliters. So you want to make sure your milliliters are in the denominator. And then that your hours are in the numerator. As long as you keep that in mind, that should help out with the with what we're doing or what you're trying to do when solving these types of equations, even if you're not the most if you don't like to do the whole dimensional analysis thing. The other thing is, you don't want to put this and just be kind of pick and choose your numbers. you want to have a system, because if you just pick and choose your numbers, you're going to get a whole bunch of different answers all over. So no, this is the 220, 230 review. So in order to do the calculation, oh, and if you're looking for the 130 class, the next 130 section is at 3:45. And then I will, and then on Thursday, it starts at noon. And then 3:45 again for 130. So somebody asked that. Okay. So I have 1,000 milliliters and I have 25,000 units. That will help me to break down or set this up. And the reason I personally like to use the dimensional analysis is because then I can eliminate units, the things I don't want, and just be left with the milliliters per hour, the things that I do want. And then all I have to do is multiply across the top, 1,000 times 1,000, and then divide by 25,000. I know it's just that easy. So 1,000 times 1,000 divided by 25,000. And then I'm left with an answer of 40 milliliters per hour. Now, this is a good practice question because you're going to do this in the Heparin protocol. You're going to do exactly this. You're going to convert units per hour to milliliters per hour. And this is essentially the conversion that you're going to be using, or this is the process that you're going to be using. And I'll show you that in just a moment. So that was question 22. For question 23, it's a similar question. It's just using insulin instead of heparin. It says that we have 500 milliliters of or 500 milliliters of an IV that contains 500 units of heparin. 500 units of insulin, and it's infusing at 10 units per hour. We want to know what the milliliters per hour is. So how do we figure that out? Well, again, as a strategy, start with what you already know. Since you're going from flow rate to flow rate, we'll just start with what we know. I guess another way to think about this is, let's say you were taking a road trip to Canada and you needed to do a conversion from miles per hour to kilometers per hour, or kilometers per hour per miles per hour. You're still going to start with the flow rate that you're working with, kilometers per hour, if you're in Canada. And then if you want to know, well, what is that in miles per hour? Then you can make that conversion. If any of you have watched Schitt's Creek, I always thought I forgot that was filmed in Canada, because you saw like some of the street signs would say like 55 or something like that. And I was like, man, that seems like a pretty fast like speed for like a residential area. And then I realized, oh, it's kilometers per hour. So if you didn't make that realization, or if you didn't see that show. Okay, so 10 units per hour. Then remember, I don't want units, right? But I do want milliliters. And I know that in my 500 milliliter IV solution, there's 500 units of insulin. And so that tells me where to put everything. Now you'll see this one's pretty easy because they cancel each other out. It's cancel out. And it's just the same answer, 10 milliliters per hour. But you don't know that unless you've done it a couple of times and you practice it. Lastly, number 24, this is more about doing a combination of things. You have 1,000 milliliter IV, it's infusing at 50 milliliters per hour. If the IV starts at 8 a.m. on Monday, what time will it finish? Sometimes they'll ask you to answer that question in military time. So you might say at 0800, and then what time will it end? Or sometimes it's in standard time, and so you can read the question and see what it says. But it tells me we have 1,000 milliliter IV and that it's infusing at 50 milliliters per hour. And I want to know how long. And if it starts at 8 a.m. on Monday, when will it end? So first thing is I need to figure out how many hours it's going to take to drain this 1,000 milliliter IV if it's infusing at 50 milliliters per hour. So the simple way of doing that is just taking the 1,000 milliliters and dividing by the 50 milliliters per hour. You'll get 20 hours. So we know how long. If it started 8 a.m. on Monday, then we have to say, okay, what time will it end, or what time will it start? I'm sorry, what time will it end if we know what time it started? So if it's 8 a.m. on Monday, so let's do 24 hours from then, right? Would be 8 a.m. on Tuesday. So 24 hours is close to 20 hours. Take away 4 hours, it would be 4 a.m. on Tuesday. Someone asked to do another one. I don't know which other one because I did 3. So if you let me know what number, and if it's the heparin one, then we're going to do a couple of those with the heparin protocol. Okay, yeah, we're going to do more of those with the heparin protocol. So you'll see that again 2 more times. All right, so let's go ahead and move into the heparin protocol. All right, so the heparin protocol, the challenge with this is just knowing what to do with the information. So I'm going to use my give me 1 second. I'm going to so I can have a little bit more control over, and it shows me a little bit more screen. All right. So for the heparin protocol, what you need to know is when we say protocol, it just means like procedures for this particular thing. So what I'm going to do is I'm going to take, it's going to take a big line here. And when we say protocol, what we mean is like, these are just like the steps of the protocol listed here. Sorry, my mouse got bumped. Okay. And then you can see there's 15 steps associated with the protocol. When we're doing the protocol, there's a couple of things we don't need to worry about, at least from the math perspective. We really don't need to worry about 3, 4, 5, 6, 7, 8, sorry, or 9. We do need to worry a little bit about 10. We do need to worry about 10, but that just restates what's stated up here in the first part of the protocol. But in order to do this protocol, all you would really need to know is the patient's weight and then what to do. Okay, so I'm going to show you what to do. Now, hopefully seeing that you don't really need to worry about all these other steps. They're just part of the protocol. It's just what's listed on the sheet A lot of this is very obviously important for when you're actually working with a patient, but for the math perspectives, we just need to know number 2, number 10, the patient's weight, and then what to do after we check the APTT. All right, so we know the patient's weight in this example is 110 pounds. When you see this on your test next week, really the only thing that changes is the patient's weight. If it ends in a whole number, great, makes it easier. If it ends in like if it's like 95.454545 kilograms, remember to round to the nearest tenth before you continue on with your other calculations. On your test, you will see 2 out of the 4 of these questions. You will most likely see A and B, but you could see C1, C2. Okay. And what I mean by that is you're going to get asked 2 questions. The first one is to calculate a bolus, and the second is to calculate an IV drip. And it's either going to be after you check the APTT, or it'll be the initial sequencing of things. So let's get a blank sheet of paper. And then let's look at a couple things. I pretty much have this memorized, so I should be able to. So we know the patient's weight is 110 pounds. You do need to know that, but we need to convert that to kilograms. You do that by dividing by 2.2, and I believe you get 50 kilograms. I apologize. In a moment, it's going to get loud because they're collecting trash here, and I think you're going to hear it clanging. So 50 kilograms is the patient's weight in kilograms. So I need to know the patient's weight in kilograms in order to do the other steps of the protocol. So let's look at the questions for heparin. It says, part A, it says to calculate the number of milliliters to administer for the bolus. So I want to know milliliters for bolus. And then and then for part B, it says, I want to know the milliliters per hour for the infusion, for the heparin IV. Okay. The other pieces of information it tells me, you can look at step 10, or you can look at the beginning of the protocol. It tells you to bolus the patient with 80 units per kilogram. That's the bolus. And then it tells me to infuse starting at 18 units per kilogram per hour. All right. So any questions on where I got those numbers from and what the, you may not know like what to do with these numbers yet, but I just want you to at least be able to know where those numbers are coming from. So I'm going to go back to the protocol. I'm getting that information that I just said is here's the bolus and the starting the IV drip information. It's also relisted in step 10. Now, the next piece of information that I'm going to need is I need a way to convert the bolus dose from units to milliliters. But before I do that, let me just show you what we're going to do calculation-wise. Okay. So for part A, Again, I'm looking for the bolus. I start with the patient's weight, and I multiply it by the 80 kilograms, 80 units per kilogram. And what I get is 4,000 units. So just like a weight-based calculation, how many units would you give? You're going to give 4,000 units. If the question asked for how many units for the bolus, you'd be done. 4,000 units, done. Okay. Let me just make sure I always feel like I messed that up. No, we're good. Now, here's where we have to do a little bit of work with the protocol. We have to figure out, just like we did in question 22, do I have a comparison for units to milliliters? Okay, and I do. So here's what we're going to do. We're going to go back to the protocol, and we're going to see in step 2, it tells me that 2 pieces of information. We have 25,000 units and 250 milliliters half normal saline. So that's going to be relative to the infusion. And then it says we have a bolus dosage strength of 1,000 units per milliliter. That bolus dosage strength is what you need in order to solve this problem. So my bolus dosage strength was 1,000 units per milliliter. Four 4,000 divided by 1,000 will give me 4 milliliters. So for a 110-pound patient, also a 50 kilogram patient, you're going to give them a 4 milliliter bolus dose to start the heparin protocol. Part B. Same patient. Now we're calculating the infusion rate. The infusion rate says 18 units per kilogram per hour. I'm going to multiply by 50 by 18. And I'm going to get 900 units per hour. Again, just like last time, I would tell you to take the if it asked what is the units per hour, we'd be done, but it is asking what is the milliliters per hour. And so I have to do a conversion. I have to do a conversion. I'm going to follow the same strategy that I followed for question 22, where I converted heparin units per hour to heparin milliliters per hour. So I'm going to follow the same strategy. I know I need to get rid of units, and I know I want milliliters, but I don't know what those numbers are. I need to find out, what do I have? What's my available? So going back to the protocol, you will see that you have heparin, 25,000 units in 250 milliliters, half normal saline. $25,000 units, 250 milliliters. Any questions where I got those numbers from? Now I just do some math. I'm going to take the 900 times 250 and then divide by 25,000. and I'm going to get 9 milliliters per hour. As a shortcut, this right here, this ratio is 1 per 100. So if you're ever looking for like a shortcut for these Heparin protocol questions, and guess what? It's always the same. I've not ever seen, if you do a Google search for Heparin protocol, you're going to see that it's the same values. So as long as it's the 250, 25,000, then you should be good. If you don't want to risk that, then obviously pay attention and double check and just do it the long hand. You still get the same answer. So this, remember how I told you before we went from units per hour to milliliters per hour? I just need to find out what this conversion is. And I find that by looking at step 2 of the protocol. Okay, going back to the protocol, it says after 6 hours, the patient has an APTT of 43 seconds. So what I'm going to do is I'm going to look in this boxed section and look at the APTT and what has changed. And I'm going to look for where does 43 seconds fall. 43 seconds falls with step 12 of the protocol. And it tells me then to rebolus with 40 units per kilogram, and then to increase the rate by 2 units per kilogram. You'll notice that, and when it says rebolus with 40, that's half, right, of the original bolus. So if you're thinking, okay, the original bolus was 4 milliliters, I'm probably going to give them 2 milliliters. You would be correct. That would be fine to do. However, if you're saying, oh, they were at 9 milliliters per hour, and if I increase the rate by 2 units per kilogram per hour, then it's going to be 11 milliliters per hour. That would be wrong. Don't do that. I did that the first time I was going through these, and I realized you can't do that. Obviously, units and milliliters are 2 different things. So we're going to calculate a new bolus, and we're going to calculate a new infusion rate. For C, part 1, patient weighs the same, right? New bolus now is 40 kilogram or 40 units per kilogram. That gives me 2,000 units. I don't want units, I want milliliters. So I need to convert units to milliliters. I'm going to do so by using the same bolus dosage strength. Remember, it was 1,000 units per milliliter. 1,000 units. And I'm going to get my initial bolus is 2 milliliters. So for bolus, I'm using the bolus dosage strength, 1/1000 or 1,000 units per milliliter. And for the infusion rate, I'm using the IV bag, 25,000 units per 250 ml or 250 ml per 25,000 units. Either way, it's fine to remember. Just make sure you organize it correctly when you're doing your math. Same patient. The next thing said to increase it by 2 units per kilogram per hour. If I started at 18, I'm going to increase it by 2. So my new calculation is 20 units per kilogram per hour. This is probably one where a lot of, I've noticed a lot of students will get like kind of stuck on this. Like, what do I do with that? You just do what it says. If it tells you to increase by 2, 18 plus 2 is 20. If it tells you to decrease by 2, 18 minus 2 is 16. If it tells you to increase by 4, it tells you to decrease by 7. You just do what it says. You just got to remember to you have to take it a step back to where you started. Don't try and do it. Don't try and do it from, where were we? Don't try and do it from like the end point, because that's where you'll go wrong if you do it that way. So we get 1,000 units. Now keep in mind, remember I do the same thing we did for question 22. We're converting heparin units per hour to heparin milliliters per hour. I'm going to use the same conversion that I used up here, 25,000 units, 150 ml. And I'm going to get an answer of 10 milliliters per hour. So what's going to change on this question? Well, I already told you the first thing that'll change is the patient's weight. Okay, so the patient's weight might be 120 pounds. It might be 237 pounds. It might be, 94 pounds. The patient's weight is what will change. The second thing that could change is it could ask you a different APTT. What if it asked you or it told you the APTT was 30 seconds? Well, then notice what you'll do. You'll rebolus with 80 units, and then you'll increase the rate by 4. So if it started at 18, then your new bolus, your new infusion rate would be set at 22 units per kilogram per hour. If it told you the APTT was 50 seconds, then you would just continue the current rate. So there'd actually be no additional, you would just continue the current flow rate, and then you would do no bolus. So my guess is on a test, you're not going to get asked just that particular question. If it's between 76 and 90, you would just affect or change the infusion rate. So you started at 18, you would go down to 2. Or you'd go down by 2 to 16 units per kilogram per hour. And then this would be, if it's greater than 90 seconds, hold for an hour, decrease the rate by 3 units per kilogram per hour. 18 minus 3 is 15. But I've only ever seen it as questions 11 or 12, because both of those require a bolus and an infusion rate for the calculation. So like I said, you'll either get A and B, or you'll get C1 and C2. One question with 2 parts to it. If you miss both parts, it's still, you only missed one question. If you miss one part of it, then you still missed one question. But now that you're seeing it, hopefully you won't miss it at all. Any questions? Or any questions on anything else you'd like to see worked through? And feel free to unmute if you want to unmute, or type into the chat. Whatever you're comfortable with is fine with me.
Would you please show the calculation for C, the last C question, please?
Yeah. Just right here.
All right, thank you.
You're welcome. And notice we followed the same exact format as B. When we're calculating or we're converting units per hour to milliliters per hour, we're going to follow the same procedure and use the same conversion there of the milliliters per unit.
All right, thank you. Good.
You're welcome. I had a question. Someone asked about question 17. All right, so for question 17, It says your patient is to receive Solumedrol 200 milligrams IV. It is received from the pharmacy in a 75 milliliter bag of dextrose 5% water to infuse over 30 minutes. Drop factor is 10. No other IVs are running. What is the correct drops per minute flow rate? So as a reminder, when you're doing flow rate or when you're doing drop rate, you need two pieces of information: flow rate, drop factor. Flow rate is 75 milliliters over 30 minutes, and your drop factor is 10. So let me work that out. So 75 milliliters, 30 minutes, times a drop factor of 10. So 75 times 10 divided by 30, and you get 25 drops per minute. Now you might be wondering, and if you ask this question, or like you were sitting there like, wait a second, there's something missing here. The thing that's missing, or the thing that you think might be missing, is the Solumedrol 200 milligrams IV. We don't really care about what the drug is. If we're calculating the flow rate, we just want to know how to deliver it or how quickly to deliver it. And the silly, example I use is if you and I are driving and we're going to take a trip, or we're going to meet each other at Kennywood, you might be driving your Maserati and I might be driving my minivan. We're both going to be probably going around the same rate of speed. It doesn't, you might be coming there a little bit more in style, and I'm going to be coming there a little bit more practical for having a family of 5, but we're both going to take around the same amount of time to get there. We're both going to be traveling around, 45 miles per hour, depending on, where we are in our travels to Kennywood. So the Solumedrol 200 milligrams, it could be phenylbarbiturates, 20 milligrams. It really doesn't matter what it is. It doesn't factor into the math part of calculating the flow rate. We just want to know if it's flowing. Are you drinking Coke? Or are you drinking Pepsi? Doesn't really matter. We just want to know how many glasses you're going through per, hour, something like that. I hope that.
Excuse me, can you show the answer again?
Yeah, it's 25.
Okay, thank you.
Yeah, and then at the end of this, the key are also where the answers are too, just in case you ever need to know that.
All right, thanks.
You're welcome. Someone else asked a question or started to.
Can you also do number 20, please?
What number?
20.
Okay. Yeah, 20. This is just 60 divided by 20, and you get 3 milliliters.
Oh, okay. Thank you.
I'll have an issue mostly with the rounding, please. I don't know. Maybe it's like question 1 and 2, something like that.
Okay. Yeah. So you never round basic unit conversions. So number 1 and number 2, there's no rounding. Okay. So the answer for number 1 is 1.275.
Yes.
Do not round basic unit conversions, meaning when you go from milligrams to grams, do not round those.
Yes.
The only time you're really going to round is if you're going from pounds to kilograms. So you're going from different units, then you would round to the nearest 10th. Or if you're talking about when you're administering a medication, then at the end of that, then you would do some rounding. But the basic rules are never round basic unit conversions. So milligrams to grams, micrograms to milligrams, milliliters to liters, liters to milliliters. You can round to the nearest 10th when you go from the American Standard units to the metric system. And then the example that you'll commonly see is going from pounds to kilograms. If you have to round when you have like a drop rate, remember, you can't give somebody a partial drop. So you have to round to the nearest whole drop. All other situations, you're typically going to be rounding to the nearest 10th. The caveat to that is if you have a number less than 1, so like 0 point something, then you would round to the nearest 100th place. As an example, in the Pfizer pen question, I think there's one here, yeah. So where this says 350,000 units, and then it says choose the strongest concentration, it's 1,000,000 units per milliliter. 350,000 divided by 1 million is 0.35. Your answer is 0.35. Do not round that to 0.4 because the number is less than 1. You want to have at least 2 significant figures when you have your answers. Now, sometimes you're going to have an answer of just 2 milliliters, so you just leave it as that. But if you have a decimal answer, and if you can, you want to let it be at 0.35. If this was 0.375, then you would round the 7 to 8, and then your answer would be 0.38. If you ever need a refresh on the rounding rules, they're right here. That's at the beginning of the packet. You should also see that in your packet. And notice that I kind of give examples here about leading zeros and trailing zeros, volumes greater than 1, volumes less than 1. Any other questions?
I'm good, thank you.
Okay, good. And you're welcome. Well, if you do not have any other questions, just know that I will be here again this evening at 5. And then on Tuesday or on Thursday, I'll be here again at 1:15 and then again at 5. So if you have any additional questions, if you can hop on here, even if it's just for a few minutes, you can always hop on. If I'm here, I'll we'll answer questions and help you out.
Thank you.
Thank you.
All right, thank
You're
you very
welcome.
much.
Yeah, you're welcome.